Hello, welcome to this video. In this video, let us take one more problem on reciprocating compressor. Let us read the problem. A 4-cylinder double acting compressor. So, a 4-cylinder means number of cylinders which are delivering the compressed air is 4. Okay. And also he has mentioned double acting compressor. Okay. Is required to compress 30 meter cube per minute. So, that means the volume which is compressed or which is to be handled by this compressor which is of 4-cylinder is 30 meter cube per minute. And please understand, whenever this type of problem is given, 30 meter cube per minute is delivered from all 4 cylinders. So, volume of air handled per cylinder has to be calculated. So, volume of air handled per cylinder has to be calculated at the starting only. So, that will be 30 meter cube per minute combining all cylinders. Now, we have 4 cylinders. So, that will be for every cylinder, this will be the volume. So, meter cube per minute, 30 by 4. 30 by 4, that is 7.5 meter cube per minute. So, each cylinder has to handle 7.5 meter cube per minute of air, or we can also convert that into second. 7.5 divided by 60. So, that will be 0.125 meter cube per second. So, 0.125 meter cube per second. So, each cylinder has to handle 0.125 meter cube per second. Now, this is measured at, now this volume which we are talking is measured at pressure 1 bar and temperature 27 degrees Celsius. So, 27 plus 273 is equal to 300 Kelvin to a pressure of 16 bar. So, delivery pressure is given now. Now, delivery pressure is denoted by P2, that is 16 bar. Determine the power of motor required. Now, we will have to determine the power of motor required and cylinder dimension, that means L, stroke length and diameter. Given speed of the compressor, now again data is given. Speed of compressor is 320 rpm. Now, clearance volume is equal to 4% of the stroke. So, Vc is equal to 4%, that is 4 by 100, 0.04 percentage of stroke, or we can write it like Vc by Vs is equal to 0.04, and we have denoted this Vc by Vs as clearance ratio capital C, alright. Then bore to stroke to bore ratio, stroke to bore ratio L by D is equal to 1.2, or we can simply write L is equal to 1.2 times of diameter if you send that diameter to the other side. Then mechanical efficiency is 80%, okay, 0.8. Now, compression and expansion index, so small n is equal to 1.32. Now, air gets heated by 12 degrees Celsius during suction stroke. Now, very important, air gets heated by, so P1 is actually, this is measured at 300 Kelvin, which is atmospheric temperature, and it is gets heated by 12 degrees Celsius. That means 27 plus 12. So, and 213, okay, 39 degrees Celsius. Then, sorry, this is not P1, this is T1, sorry. So, this is T1 is 27 plus 12, 39 degrees Celsius, or let us convert this into Kelvin. 39 plus 273 will be 312 Kelvin. Now, this is the actual temperature, but whereas the measured value is in this condition, alright. Now, measured value in this condition, in the sense the values which are measured, the volume of air handled is measured at different temperature. Now, we will have to convert this into our inlet temperature. So, what we can write it is like, we always use this equation. Now, P, this let us say we denote this by F. So, that is some stage where free air delivery is measured. So, Pf Vf by Tf. So, Pv by T is equal to constant. This must be equal to P1, and the volume of air handled we call it as VES, okay, effective swept volume. So, divided by T1. So, this has been given to us. So, 1 bar. So, you can calculate 1 into 10 power 5, and volume of air handled you can write it like 0.125 meter cube per second, and temperature is 300 Kelvin. This must be equal to, now P1 is again pressure, is not given any changes in pressure, whereas this is VES, and T1 is 312 Kelvin. Now, this 10 power 5, 10 power 5 goes off, we can only do the remaining calculation, all right. So, that is 0.125 divided by 300 will be the left side, and this will be multiplied by 312, we will get VES. Now, effective swept volume will be 0.13. Effective swept volume will be 0.13 meter cube per second. 0.13 meter cube per second. Now, let us go for volumetric efficiency equation. Now, we already know the equation for volumetric efficiency. Now, volumetric efficiency is given by 1 minus C into Rp power 1 by n minus 1. Now, what is 1 minus C is 0.04, and Rp is 17 by 1 bar. So, Rp is, now Rp can be calculated from here. Rp is equal to P2 by P1. Now, P2 is 17 bar, all right. P2 is 17 bar, and yeah, P2 did we miss? P2 16 bar. So, P2 is 16 bar divided by 1. So, this is 16. So, 1 minus this is 16 power 1 by 1.32. So, n value is given 1.32 minus 1. So, this will give us the volumetric efficiency 1 minus 0.04 into 16 power 1 by 1.32 minus 1. So, that will be 71.32 percentage. 71.32 percentage. This is our volumetric efficiency. Now, let us use this volumetric efficiency and find out, let us use this volumetric efficiency is equal to VES by Vs. Now, volumetric efficiency is 0.7132. This must be equal to Vs is 0.13 divided by Vs. Now, therefore, Vs will be 0.13 divided by 0.7132. Now, that will be our swept volume 0.13 divided by 0.7132. So, that will be 0.182 meter cube per second, 0.182 meter cube per second. That will be our swept volume. Now, we know that this swept volume is equal to, pi d square by 4. Now, this swept volume is swept volume of individual cylinder. So, pi d square by 4 into length into the rotation, the RPM divided by 60, because left side is in meter cube per second, and multiplied by 2. So, we know that multiplied by 2 because double acting cylinder, Okay. Now, Vs is 0.182 is equal to pi d square divided by 4. L is actually 1.2 times of diameter multiplied by n is 320 by 60 multiplied by 2. Now, this can be further simplified just to keep it simple for the calculator. Now, this is pi into d cube into 1.2. This 2 goes with this 2 and we will have 320 by 2 into 60. Now, the only unknown is diameter. I think we should be able to calculate the value of diameter. Now, let us go for 0.182. Alpha equals shift pi into alpha x power 3 multiplied by 1.2 multiplied by 320 divided by 2 into 60. Shift solve for x is equal to 0. We will have 0.262, that is diameter is 0.262 meter cube, and L is equal to, we know, 1.2 times of diameter. So, 1.2 times of diameter will be 1.2 times of diameter will be 1.2 multiplied by 0.262, 0.314, 0.314 diameter, sorry, meter, diameter is in meter. Now, this is 0.314 meter. Now, let us go for power. Now, work transfer is given by n by n minus 1 of P1 Vs into Rp power n minus 1 by n minus 1. And remember, we are talking about a problem with clearance volume, because the moment clearance volume is given, we were supposed to draw this PV diagram, and we know that with clearance volume goes like this. Okay, we should have drawn this earlier only. So, there is compression, polytropic compression and polytropic expansion. There is pressure constant delivery, pressure constant suction. These are 1, 2, 3 and 4. Okay. Now, n is given 1.32, is that correct? Yeah, the value of n is 1.32. So, 1.32 divided by 1.32 minus 1. Now, P1 is 1 bar, so 1 into 10 power 5, and VES is calculated 0.13 and Rp is 16 power 1.32 minus 1 divided by 1.32 minus 1. Now, this will give us work in watt, because we have units in watt. Let us check it. So, first let us calculate 1.32 divided by, this will be 1.32 minus 1 into 1 into 10 power 5 multiplied by 0.13, okay, multiplied by 16 power 1.32 minus 1 divided by 1.32 minus 1. So, that will be 51.395 into 10 power 3. 51.395 into 10 power 3. Now, that will be watt, because pressure is substituted in Newton per meter square, and the effective swept volume is in meter cube per second, and none of the other quantities here has units. So, meter square goes of Newton meter per second, which is joule per second, is watts. So, for every cylinder, we can write that the work required will be 51.395 kilowatt per cylinder. But we have 4 cylinders here. which are working simultaneously to deliver the volume of air. So, this must be multiplied for 4 cylinders. We must multiply that 4 into 51.395. So, kilowatt. So, that will be 4 into 51.395 kilowatt. So, that will be 205.58 kilowatts of power needed. But remember, the mechanical efficiency is given. So, mechanical efficiency is something like this is ideal efficiency, but you are giving energy to the compressor. So, if this is your motor and this is our compressor, okay, this is our compressor, this is our motor. So, this requires 205.58 kilowatt, but whereas motor needs to be supplied more because there is some amount of energy which is lost in between. So, that is what is we are calling it as mechanical efficiency. So, we can say that this has to be now actual power required must be greater than this. So, that is 205.58 divided by mechanical efficiency. Now, what was mechanical efficiency was given as 80%. So, 80% means 205.58 divided by 0.8. Okay. So, we need more than this 205.58 divided by 0.8. So, that will be 256.975 kilowatt. So, this will be the actual power required at the motor. Okay. So, this is the indicated power or power required at the motor. Thank you.